Hello, good morning, members. Welcome to today's webinar session, Gyan Ganga 37 number. Hello, good morning, madam, members. A very warm welcome from Team Training and Education of ISLA. Today we have 37th session of Gyan Ganga webinar series. Today's our topic is cracks in building, and we have our panelist, Mr. KB Manchanda and Mr. Naresh Kumar Tagotra. Since Manchanda ji is regular faculty at our webinar, need not give to more introduction about Mr. Manchanda. Yes, Mr. Today we have another co-panelist with Mr. Manchanda is Mr. Naresh Kumar Tagotra. He is BE Civil, specialization in structural engineering, working as a surveyor for last 27 years, having worked with military engineering service and public health engineering department. So I welcome to Mr. Naresh Kumar Tagotra and Mr. KB Manchanda. I also welcome to all the ISLA members, and I request Mr. Manchanda ji and Mr. Naresh Kumar Tagotra ji to start today's session.
Yeah, welcome friends. I welcome you all from myself and from Mr. N.K. Tagotra, who is co-host today and one of my buddies, and we have attended so many losses together, and we are co-investigators for CBI and as well as for Vigilance Department of Insurance Companies, and we have cracked so many cases, and definitely he has been of great help to me, and I today am presenting a paper with the help of Mr. Tagotra, which was not possible for me to prepare such in-depth and profound kind of write-up. So today we have picked up a topic that is cracks in building. What are the reasons behind it, and how do they occur, whether they are payable under different policies, and if they are payable, how we have to take care of them. So let us begin, and I hope this webinar is going to give you much more knowledge about the cracks, because what I feel is every crack is a story, and let us come and explore it. So, cracks in civil works. Every crack is a puzzle. Let us solve it. Fine. So today it is what we are about to take care of. It means, just hold on. Let me set right my screen, because just now. While minor cracks in the walls of your home are part of the happiness of living, it is extremely important to contact your builder or contractor right away if you become concerned that a serious crack issue may be in developing, as any crack exceeding 3 mm requires your concern and detailed analysis of the building and its surroundings. Even the soil testing is recommended in that condition. So there are certain cracks which are dangerous to the structure, and there are certain cracks which are not dangerous. So this is what we have to make analysis of, because whenever an estimate comes, and because of our uh, ignorance, we may be in a position that we are not assessing the liability in the right perspective as we should have to. So this is our endeavor to let us take you to the cracks. Let us visit them. How do they occur? What are the forces behind them? What are the reasons and all? So this is what we have to take care of. Now, cracks in the buildings of common occurrence. A building component develops cracks whenever stress in the component exceeds its strength. Stress in a building component could be caused by externally applied forces such as dead or live wind or seismic loads or foundation settlement, or it could be induced internally due to thermal movements, moisture changes, and chemical actions. So these are the basic reasons which cause cracks to happen in any masonry work or in any civil construction work. And sometimes it is maybe misappropriated or about our mixture when we are trying to put more cement or less cement. Even then, because of that composition, the proper bonding is not there, and that is also going to make some cracks somewhere, sometime. It may be instant or may develop with time. And there are certain cracks which do develop in a building because of its aging. We will discuss it. And secondly, we must say cracks could be broadly classified as structural or non-structural. Uh, Structural cracks are those which are due to incorrect design. You see, whenever any design failure occurs, that is only because of this reason. And these cracks are very much dangerous to the extent that you have to even demolish, even government authority can uh, order for demolition of such building. And faulty construction or overloading or incorrect design or design faults, these are all exclusions in all of the policies, except uh, car policies, engineering policies, because they have got uh, covered in those policies, because now those are turnkey basis policies, or rather tailor-made basis policies. These sort of policies are covered in that one, but definitely they are not covered here. So shrinkage or thermal movement is an instance of non-structural cracking. You see, whenever you lay foundation or construct walls, or even you lay RCC slab over the superstructure, you see, because of its because of its yeah because of you see, it has to be properly cured, and for 20 days, 15 days, that is the minimum. That is depending upon what you call the grading of the cement. Maybe 33 grade you use, or 43 or 53. Likewise, the days decrease because setting time is earlier. That setting time, whenever the cement is being set, there is evolution of heat. That heat is quite by the curing. And secondly, after 20 days, when whole of the RCC slab is completely dried, so it shrinks, and that shrinkage may cause its movement or its shifting towards inside or maybe outside, whatsoever, wherever the forces are taking it. That depends on the design. So the RCC slab may not have a bonding with the walls, so that cracks because of shrinkage, or thermal movement cracks, or the cracks which are developed because of the weather conditions, say in the hot or humid, what you call weather. The torch steel longitudinal bars, they expand, and these are the what you call it, These are the temperature parts. When they expand, and even then, there is a crack which is developed within the RCC slab, and these are not dangerous. These are mostly occurring because of the phenomena, and definitely these cracks are not dangerous. So, but here I would say that cracks in buildings are of common occurrence, as we have said, because every building is designed keeping in view the dead or live load, wind or seismic load, and foundation settlement. So these are the things which are to be taken care of whenever we are planning to construct any building. Now, yes, now we have classified some of the common causes uh, which create cracks or which develop cracks in the buildings which are enumerated as moisture changes, thermal variations, elastic deformation, creep, chemical reaction, foundation movement, and settlement of soil and vegetation. So these are the most probable reasons which are encountered while we see any cracks which are formed. They are only because of this. The crack which I earlier have been discussing, you see the photograph here, you will find that RCC slab and the brickwork, they both are not having any bonding between them. That is why a crack has surfaced, and that crack is due to different movement of RCC and current brickwork in the wall. In the wall side, it is because I told you because of the composition and the time between the RCC slab and construction of the wall, that cement bonding is not there. And you will see that whenever a dam is constructed, it is constructed in different zigzag kind of blocks, so that if there is any seepage because of non-bonding of that is contained by the zigzag surfaces. So that is the main reason to contain the seepage in the dams, because you know the water pressure is quite high in so we have to see this loss has occurred only because of faulty construction, because we have not given a proper bend in the temperature bars, because with that way it has to come back to 1/8 of the right 1/8 of the total length of it. So that will be contained. Now you can explain it much better.
Yeah, this is due to
Unmute.
eco.
Okay. Yeah.
This is due to different movement. Actually, the brickwork expands in a different way, and the RCC expands in a different way. Now, due to heat, because it is in direct sunlight, the RCC will expand more, and the brickwork will expand less.
Because of the exposed
that
because of the exposed surface to the sun
Yeah.
rays and
No,
temperature.
no,
Okay.
because of that, there is a differential movement of RCC and the brickwork, and that causes this type of crack.
Fine. Let us go to next slide. So now, first of all, we will discuss moisture as a cause of the cracks in the building. The building materials having pores in their structure in the form of intermolecular space, as for example, concrete, mortar, burnt cork, bricks, stones, timber, expand on absorbing moisture and shrink on drying. These movements are reversible, because in every monsoon you will see that your doors are not closing properly, and in extreme hot weather, means in summer or in winter, they are working quite fine. But in the moisture, whenever the moisture is there, in those days, your doors are not working well. They are not closing. So these are reversible because with time they come back to its own prepossessing position. So apart from the reversible movement, certain materials undergo born irreversible movement due to initial moisture changes after their manufacture or construction. Instances of irreversible movements in the material are shrinkage of cement and lime-based materials on initial drying, and expansion in burnt clay bricks and other clay products on removal from kilns. Fine. Now, this is basically a moisture, how moisture is acting upon the different quality of materials. Whenever fresh brick is taken out of the kiln and it is having lots of pores, because a brick absorbs 3 times of its weight, the moisture it can absorb. So that way it expands. Uh, and likewise, whenever we are laying some RCC work, and because of heat which is generated on the chemical reaction in contact with moisture, so it also expands. Then initial drying, after initial drying, these are the changes which cannot be put back into their prepossessing state because they have changed their uh, quality, they have changed their characteristics, and definitely these are all things which are taken into consideration while we are making a home. Now, initial shrinkage depends upon cement and aggregate. This is richer the cement, more the drying shrinkage. Fine. It means we have got to use the absolute recommended mortar or aggregate or mixture of sand, pebble, aggregate, and cement. Because 10% more volume of aggregate reduces 50% shrinkage. Means if we are putting 10% more stone of shingles or aggregate, we can reduce the shrinkage by 50%. Means shrinkage is not in meters or whatever. It may be in mm. Say if it is shrinkage is say 2 mm, that can be reduced to 1 mm by putting 10% more. But definitely there is a set procedure. You cannot go beyond that also. Otherwise your structure is going to be compromised, and definitely it will be coming under strains which it cannot withstand and may collapse prematurely. Fine. Then water content, more the water content, more the drying shrinkage. Implies if water content is less and the using vibrator, the placing done will cause less shrinkage. It means whenever there are air pockets left within the RCC, and if we are not taking care of it by using uh, vibrators and all, and definitely you can uh, see that whenever it is exposed to extreme heat or cold, definitely it will develop crack because air is compressed more quickly or is expanded more quickly as compared with the solid objects. And the other factors such as chemical accelerators, curing, humidity, temperature, this is what we have discussed earlier. These factors are the factors which definitely cause the cracks to happen, because if we are constructing a home or in quite dry kind of atmosphere, the cracks will be evident quickly because moisture is required to take care of the chemical take care of the chemical reactions which are happening within the cement in contact with the water. So that way they keep on happening until 1 month. That is why if RCC slab is done in the uh, monsoon times, it will give you much more durability. Now, here we come, the second cause, which is causing cracks. That is the thermal movement, and all the materials expand and contract due to cyclic temperature variations, and magnitude of movement depends on each material's molecular structure. If there is restraint in movement, when tensile or shear stresses are caused, resulting in cracks. Further at joints, location of two materials will have differential thermal moment, and thereby cracks at such points are common. You see, thermal moment, it happens most of the times in RCC slab because it has got a wider exposed surface uh, to sun and to the heat, and definitely, all these cracks which we see along with the horizontal, along with the front elevation or the side elevation, where the RCC structure is, RCC slab is, we will find all these losses of cracks happening there, and definitely this is because of thermal moment, because most of the time what we keep on saving on the torch steel bars, because these thermal moment cracks can be contained by bending the temperature bars to a certain length inwardly, so that that ex- that expansion of torch steel goes inwardly, and definitely then cracks won't appear. But in fact, for cost cutting, generally that doesn't happen, and definitely because of that stress which is caused by the expansion on the walls, the joints are dislocated, joint of wall and roof are dislocated, thereby causing very minor cracks. And definitely these are the cracks which are not instant and not payable in any policy. And these are caused because of uh, cutting the cost of the construction, and are slow in process, and gradual things which do happen, they are not covered. And definitely this thermal movement losses, which happen mostly along the RCC slab, are not covered. Now, elastic deformation, structural component of a building such as walls, columns, beams, and slabs generally consist of materials like masonry, concrete, steel, etc. undergo elastic deformation due to load in accordance with Hooke's law. The amount of deformation depends on elastic modulus of the material, dimensions, magnitude of loading, and dimension of the components. Now, here is an example. A load-bearing wall having large opening will cause differential strain in loaded and unloaded wall. In figure A, will act as pillars, and B stress B portion, resulting in differential stresses and vertical shear cracks can occur, and same can be avoided by RCC lintel or slabs over opening having shear resistance. Means we have to have lintel or RCC slabs, or maybe even your wooden lintels can do to contain such sort of losses. And these losses are again because of elastic deformation, and these losses again are not payable in the policies. But most of the times, whenever any earthquake comes, and most of the surveyors, they do give such losses, but definitely these are not because of earthquake. So you please make sure of this. Am I right? Yeah. Now, if glazed terrazzo or marble tiles are fixed to a masonry wall too soon, that is before the wall has undergone normal strain due to elastic deformation. You see, all these things, they occur while things are being constructed. When a building is being constructed, these are instantaneous, because the load, if it is not distributed properly or a big opening is there in the wall, definitely there elastic deformation is likely to occur, and sometimes we people while constructing laws we have to shift inside, Indian mentality, do it fast, and they don't give enough of time to settle the such sort of elasticity of the materials itself, and they fix marble tiles or terrazzo or glazed tiles or maybe plastering, so that develops crack even before you have shifted into it. And thereafter, your contractor does what he simply tries to fake this or cover these up by putting putin and everything and then doing whitewashing. And definitely, these sort of losses which are not payable and should not be considered ever, because being a surveyor, you are there to give him losses which are defined in the policy, because none of the policy is all risk policy. Even all risk policy or not all risk policy, exclusions are still there. So shrinkage at drawing shrinkage and creep, excessive shear stress is likely to develop at interface of masonry and tile, resulting in dislodging or cracking of tiles. It is thus necessary to allow adequate time lag between work of wall masonry and fixing of the tiles. This is what I'm saying. We people don't give whenever it is near completion. We say every uh, type of worker, masonry work is also going on, and joinery work is also going on, and painting is also going on from one end. So we are not giving enough of time to settle the things properly, so that you can live tension free thereafter for years altogether, because A grade one building conforming to A category, its normal usage of the building is near about 75 years minimum. And if it is frame structure, it is RCC structure, then its life is treated as 100 years. So likewise, we have to apply depreciation whenever we have to apply a depreciation on conventional house or a conventional construction. We have to apply accordingly depreciation. For first year, we have got to take 2% or maybe 3%, and for rest of the time you have to divide rest of the period by 100 and keep it maybe 7.75%, maybe the rest of the period you have to, or maybe 1% or maybe 1.25% or 1.5%, that you have got to see, and you have got to go through the different manuals and CPW schedules regarding that. So you have to keep all these things in mind while you are assessing the loss. Now we come to creep and chemicals. Some building items such as concrete, brickwork, and timber, when subjected to sustained load, not only undergo instantaneous elastic deformation but also exhibit a gradual and slow time dependent deformation known as creep or plastic cast strain. Like, I will give you an example here. Whenever you are pressing anything down, and it has got elasticity, it will come back. But definitely it will not come back to its position where it was. With every pressure, it will develop creeps, that is called creep. And these creep losses, these are again gradual losses, and our policies don't cover gradual losses. Now, and they are slow and time dependent deformation, and our all pulses, they are covering instantaneous losses which are happening within a wink of an eye, which is unexpected. This is expected, this is gradual, this is happening, and you can't see it is happening until unless uh, you are particularly seeing it. Otherwise, you look around yourself, you may see thousands of cracks in your walls. Right now, you just have a look on it. So these are the creep or temperature damage, thermal elasticity, or whatever. These sort of losses, these are definitely not payable in the policies. We must take care of it. Yes, as I have said earlier, some engineering policies, car or they may have because they cover fault also. If some wrong fault or miscalculation is there, say if any bridge is being constructed and there is some miscalculation of even any item, or if any item is little bit put more extra, so it may not withstand and will not give you the service as what it has been constructed. So this phenomena is known as creep, and we have to take care of it. We have to see uh, these losses are occurring where? I tell you, these losses, most of the time, they occur in bridges, right? You go to any bridge, you will find minor cracks because of dead load and rolling load are calculated to, but definitely there are certain times whenever there is a traffic jam and the lorries have to stop over the bridge itself. So that way, it is bridge is not only made for rolling load, but also is made for the dead load also. So both of the combinations have to be taken care of while we are uh, arriving at or designing a bridge. So there is a provision which is given for creep also by way of steel wires. Because PCC construction, especially, I will give you an example of a PCC box type construction bridge. They are tied with ropes. This I'm talking about the suspension bridge, where two pillars are on the either of the bank of the river or rivulet or nala or whatsoever. So these are tied with the what you call rope, and that is not visible. That is going through the PCC box itself. That is why it is called PCC box type structure. So we have to see these creep losses. They are gradual in happening, and these are taken care of by the designers of the bridge, by the person who has designed, and by the person who has designed its structural uh, designing of the uh, all these things are taken care of. Then in AutoCAD there is a uh, artificial kind of situation is made and is given to the test, and with all its parameters are fed into it, and thereafter computer calculates what is the dead load or required for a particular span of the bridge. At low stress, it is thought to be due to seepage and viscous flow. At the high stress, it may be due to intercrystalline slip and microcracking. I guess, Tagotra, you have to answer this. Yeah, at low stress, this paragraph.
At low stress, the, the water seeps in, and due to that, there is a viscous flow in the material, and and
That viscous flow is because of the creeps which has been made by the
yeah,
rolling load.
yeah,
Fine,
yeah,
good.
and and at a high stress, it is a intercrystalline slip. That is micro cracking
Very
do
right.
occur,
Yeah,
and uh, it's a micro failure in
in the
the
construction material.
structure.
Yeah, structure
Yeah,
material. But that is not dangerous.
yeah, it is not dangerous. Creep is not
Eh,
dangerous.
Okay. Now,
We are discussing only these
yes, which are
which are not dangerous.
not dangerous. Fine. Now, certain chemical reactions in building materials result in appreciable increase in volume of the material. And internal stresses are set up which may result in outward thrust and formation of cracks. Fine. It happens in RCC roof also on the platform on the well, that is why there are gaps are given to contain these. Volume of the material increases with whenever it is exposed to heat, It is again because chemical reaction is always because of presence of heat, or it evolves, sometimes it evolves heat, or it is developed by heat itself. Am I right? So these are the things like RCC slab, that it goes outwardly, and RCC slab is resting upon brickwork, brick wall. That way, brick wall will give it a place, and a crack will happen. Fine. So, so we have to see that all these chemical reactions which are being well, because you would have seen that sulfate kind of material is coming out of the brick, white powdery material, fluffy kind of thing that is coming out of the brick, and definitely that is also because of some chemical reaction, because of the moisture or heat or whatever it has operated upon to. But sometimes that is becoming so much enormous that it gives or vents off in the shape of a crack. Am I right? This is what it's going to be. So commonly instances of this phenomena are sulfate attack on cement products, carbonation in cement-based material, corrosion of reinforcement in concrete, and brickwork and alkali aggregate reaction. Now, will you please
Actually, RCC is having two material. One is cement, and other is the steel bars.
why?
No, steel bars do corrode due to chemical reaction, and they
And
go
seepage
in
of
oxidation,
water
and
and oxidation
due to
will occur.
seepage of
Yeah.
water, oxidation will occur, and it will start
Decay.
to deteriorate.
Yeah. Or decay.
So in such of a decay, in when the building is having age of 20 to 25 years, you will see that sunshades
Will fall
or
off.
cantilever type
Structures will fall off.
constructions, they may fall,
Yeah.
or they will start to show cracks at about 5 to 7 years age.
Very right. So this is what we have given the example also. One such example of chemical reaction is corrosion of reinforcement in RCC, and common site is RCC sunshades or cantilever kind of thing. Sometimes you see the basic structure is extended on the first floor by 3 foot or 2.5 feet of the projection. You would have seen in your cities also. This happens everywhere, especially when a plot is a corner plot. They do it. They do it, and that structure, that 2.5 feet, which is extended, that is exposed to all the stresses because the building has not been designed. And even if it is designed and given cantilevers, definitely it is exposed to weather conditions, and because of weathering, the plastering will give away because of cracks. Oxidation will occur within RCC tall steel bars, and one time will come that corrosion will be to that extent that upper layers, in layers, it corrodes because it is not going direct to the core of the tall steel bar, and that crest which are then, if a crack is there, they do not hold good and they fall off because of their own weight. And that happens after around 20 to 25 years, maybe 30 years, maybe 15 years, because of the conditions of the weather and other things. Because if seepage is there, more corrosion will be there. And if your bathroom pipe is leaking, and that urination, because that is acidic, and that will yeah, corrode it more fast. So all these conditions we have to be a very meticulous while we are assessing the loss or when we are reporting the loss, we should observe each and everything minutely, and preferably we have to take care of everything, and we should write on papers, because whenever the report is mature, we, because of some reason or other, or the stresses of our profession, we definitely are forgetting some of the things which are maybe so important that the fate of a claim is depending upon them, and we may forget when we are making the report. So it is better to have a diary and paper with you and write down all the things, meticulous examination, and uh, you spend 5 minutes extra on the site and note down, so that you may not have to rush to that site once more. So creep and chemicals is again one category of the loss which causes cracks, and these chemical reactions or creep formation, it is not instantaneous, it is gradual, it is happening with passage of time, and none of our policy covers such sort of decaying procedure or phenomena. Fine. Now let us go to another reason. Now here it is the main, and most of the times we are more confused about these sort of losses. This is foundation movement and settlement of soil. You see shear cracks, as you see in the uh, photograph, this drawing. The shear cracks, these sort of cracks are called shear cracks. Shear cracks in building occur when there is a large differential settlement of foundation, either due to unequal bearing pressure under different parts of the structure, or due to bearing pressure on soil being in excess of safe bearing strength of the soil, or due to low factor of safety in design of foundation. So again, this loss, in our opinion, is happening because of uh, design failure, because you have not followed either design, or you have used substandard material, or you have not given enough of time to settle down the things, because of the reason I have told you, that whenever somebody wants to make the construct the house, he immediately wants to do all the things within no time. He wants to even shift into it. So you have got to give everything a proper time to settle down. Only then you have to start the another process. So previously, if you go 15 years back, or maybe 20 years back, whenever foundation used to be constructed, it was left for at least two monsoons. It has to see, then only brickwork used to be started. Am I right or wrong? So right now people don't have much time, and that is why this settlement of uh, foundation is quite often there, and shear cracks are being observed there. So shear cracks in building occur when there is a large differential settlement of foundation, either due to unequal bearing of pressure, and sometimes it may be that they have excavated and they have done it, they have not used vibrator or other things to settle down. Compaction, soil compaction is not done. So many other reasons also. But here I would say that our policies, especially fire and shopkeeper and householder policy, they do not cover the settlement of the made up ground. They don't cover the design failures. This is also case of design failure. Now here we come to the other thing. Buildings are constructed on shrinkable clays. Means building has been constructed without giving any consideration to the soil, because every soil is not any soil near the river may have different characteristics. On the other region it may have different. In south there are different kind of soils, and so everywhere the construction of a building depends on the weather conditions. Like in uh, you go to Kashmir or you go to Himachal or you go to Uttarakhand, they have a different structure characteristics because of uh, not to let accumulation of snow over the rooftop. They have gable type of structure at the end, and they call it attic floor, and that is called king post kind of design of the CGI roofing. Am I right? Uh, then roots of fast growing trees. This is another cause. And most of the time, whenever we will discuss it later also, whenever you go and find that somebody has uh, reported a loss of his compound wall, most of the time it happens in compound walls and or any garden which they have in front or on the rear of the house. They have some uh, trees like mango or whether they are fast growing and their roots go deep down and they disturb the building. So we will discuss in coming text. Building on built up soil having lesser compaction. Again, this is exclusion of the policy, but we have to be meticulous. We have to see and how you have to come to this conclusion that it is built up soil having lesser compaction. This is made up ground, which is an exclusion. It will definitely come to you with passage of time because experience teaches so many things which your books don't. Now, at inadequate plinth production, causing seepage of rainwater, etc., to the foundation. Like whenever we are constructing and building, and whenever it is constructed, there is a DPC level. From DPC level, whatever is the exposed surface of the foundation, we have to cover it with plaster, and we have to make a what you call
We give protection to the
protection plinth in way of that extra
PCC. Yeah.
yeah, fine. So all these things we have to do to protect because the more water is seeped in, more the soil will be compacted and your structure will start to shrink gradually. And definitely that is not a case of subsidence, that is case of uh,
Settlement of soil.
settlement of soil because of in what you can say design failures. I mean, you have not constructed it well, bad workmanship kind of thing will come into place, and that loss is not again payable. No, permeability of concrete. The deterioration process in concrete starts with the penetration of several aggressive agents and is a major cause of cracks on wall. Essentially, dictates that the capacity of concrete to survive weathering action, chemical attack, or any other process of deterioration. Hence, low permeability is the main factor to concrete resilience. There are several factors which control concrete permeability, water cement ratio, number one, number two, curing, number three, air voids due to deficient compaction, number fifth is use of mixtures. Number six is micro cracks due to loading. Number seven is cyclic exposure to thermal differences and oldness of the concrete. Now I request Mr. Tagotra to please.
The concrete, once it's placed, it starts to deteriorate because you can say it starts to depreciate. Now, the
You are saying about which concrete, which has been mixed with water,
yeah,
immediate and has not been put to use. Like sometimes I have seen that they cover it with sand and they go and next day they again come and put some more water and try to
no,
fix it.
not that.
Okay.
So it's a say once we have placed a RCC slab on the roof. No, all the weathering action, all the chemical reactions they start to
take place
yeah,
immediately
take place. Yeah.
because the cement, when in contact with water, a chemical reaction takes place, and
Once-
every chemical reaction, when it takes place, it evolves heat, and that heat has to be quenched by putting on water. When it is even put in lesser quantity, even then cracks will occur.
No, in lesser water, the cracks will be less.
But will occur.
Yeah,
I'm saying
water
will
cement
occur.
ratio should
Fine.
be maintained.
Yes, that has to be maintained. And even if it is for longer periods, that is also again not good. So it has to be done under the proper supervision. And now you please tell me, what is the low permeability towards the concrete resilience? What you want to convey here?
मैं अगर थोड़ा अटक गया
नहीं नहीं कोई बात नहीं. You take your time. Nothing to worry. So low permeability is main factor to no, nothing to worry. Concrete resilience means if permeability is uh, letting the viscous material pass through it, and that can be contained by compacting by vibration or whatever.
Yeah, actually, this is one thing
Huh.
that if permeability means porosity.
That is what I'm
No,
saying.
that
That
is the
will allow
porosity.
water to flow
Yeah.
into it.
No,
Yes.
if concrete is having low permeability, that means it will be a dense concrete.
Yes.
No, if it is a dense concrete, water won't allow water to percolate. That means
On the other surface.
low water will percolate into it.
Yes.
That will increase its strength, and it will not be
and will
affected more
decrease
by these.
and decrease its elasticity, you want to say.
Yeah.
Then, now, micro cracks due to loading, cyclic exposure of thermal differences, and oldness of concrete. Fine. So these are the things we have to take care of while we are making any structure. The permeability of cement mixture is a function of water cement ratio given grade, quality material, suitable for portioning, and good construction practice. The permeability of the concrete is great function of the interconnection and porosity of pores of the cement paste. So, so wherever bad workmanship comes, this defect will come. Number one.
Yeah.
And bad workmanship or structure defects, they are not payable. Any loss which is occurring because of this is again out of the scope of the policies which we are discussing. Right? Now, here we give some examples. This is brick aggregate in base concrete of the flooring contains high soluble sulfates, more than 1%, and water table is high so as to cause long spells of dampness in the base concrete. This now I don't know, but so anyway, you see the letter will they I don't know whether they will be yes okay you do it. You see the water table is high at the base here. Where is here? It will be great
Touching
touching. Okay,
this
base
is ground
concrete.
level.
Yeah, ground level. I know. Touching the base concrete, the latter will, in course of time, swell up, resulting in upheaving and cracking of the concrete. Like I give you an example, when we have a RCC slab, uh, mm, okay, let us take example of RCC slab. Because of because for insulation, so that heat is not coming to the interior of the building, we provide brickwork over it after using tile work over it after using mud. Am I right? And whenever that permeability of water is there, water is let into it, and it will be here, and when it will be deposited here, and when it will be deposited here, and it will, when it is evaporated thereafter in the dry days, it will swell from the middle, and whenever you will walk over it, it will collapse. This is what I could understand from this.
No, this is
ठीक? Okay, upheaving, and that upheaving, this upheaving is ऊपर उठ जाना. That will cause pressure this way to this wall and to this wall. These may be your retaining walls over your rooftop, and they may crack at bottom along the roof side. Again, this loss is gradual in nature. It will not happen. So cracking of a compound wall due to growing roots under the foundation, this is what we were talking earlier. So you see this, this is the root, this is the root, and when it will grow, it will swell, and it will develop a crack first, and then there will be a gap. It will uh, bring upward, uplift it, and you will find a gap in it. And definitely, this is again because of uh, roots, and is a gradual one, and definitely it is again not payable. Because sometimes if tree is cut at trunk level and roots remain below foundation, the root will shrink with the time, and thereafter there will be a gap, and again a crack will occur, and that crack is only because of that. And definitely we are not covering these sort of losses. Now, vertical cracks around staircase opening caused due to drying, shrinkage, and thermal movement. So you see in this building, because of thermal shrinkage, uh, thermal movement and shrinkage and drying movement, losses are likely to occur at these weak points, these points where
large openings.
large openings are there, and no RCC or wooden lintels are provided. The cracks will develop here. Now, vertical cracks around the balconies due to drying, shrinkage, and thermal movement. So you see, this is again, this is the balcony, and this is resting either on a reinforced cantilever kind of construction, or maybe because of this, it will, because of expansion of cracks, it will make more expansion, and definitely pushing the wall from here and developing a crack here. Again, this is the what you call your sunshade, which will expand from here because it is a far and definitely it is going to develop a crack here. And these are the vertical cracks, and these are again because of shrinkage and thermal movement. So these cracks are not payable. Now, horizontal cracks below RCC slab, that is what we have discussed earlier. Horizontal cracks in the topmost story below slab due to shrinkage and deflection of slab because of temperature variations, and all that is what we have discussed. This will happen because on first floor or ground floor it will not happen, because the weight of whole of the structure is resting on it. It won't let it happen, and that is upliftment of the RCC slab, or this will happen like this. So you can see the crack here because of all these movements, and shrinkage or deflection of slab, or maybe because of thermal movement, everything we have got to see. Now here we come on this another. We are sorry that we have not given a figure number. Otherwise, it would have been easy for us also to discuss. So we will try to give you much more quality, because we are also in learning stage. Now, horizontal cracks at top story window lintel level due to pull exerted by slab due to drying, shrinkage, and thermal contraction. So here, these are the losses. Either they are called by made by either expansion or contraction because of the atmospheric thermal movement. And again, it is a very slow happening process because here the slab will expand and it will pull along this because of large openings. This is a weak portion and it will pull along with it and it will develop a crack. So another example is here horizontal cracks at corner of the top story due to lifting of corners of building caused by deflection of in slabs, prevented by sorry prevented by making provisions of corner reinforcement in design. So this is what I have been uh, telling you that in cost cutting or in saving on some money because we have to hold the uh, temperature bars because there are two type of bars used in RCC slab. One is called uh, temperature bar, other is called load bars. Fine, and temperature bars have to be folded 1/8 of its length on both sides so that any expansion is coming back within so that there is no upliftment of corners. So 1/8 and 1/8 means 1/4 means 25% you have to pay extra for it and nobody pays, and that is why these losses do occur, and that is bad workmanship or design failure kind of thing. And this is all again out of the scope of the policy, which we don't have to. Now here we come diagonal cracks in brick masonry over lintel of the long span opening due to shrinkage of concrete. You see, whenever anything is dried, it shrinks. Whenever anything is exposed to uh, cold conditions, it again shrinks. Whenever anything is exposed to heat, it expands. So this diagonal cracks, they do come not only because of they are formed not only because of expansion, they do are formed because of contraction of the concrete in the hostile weathers. Fine. Now, corner cracks in panels of concrete flooring occur because of the curling up of corners due to differential shrinkage between the top and bottom of the slab. When load comes on the floor, curled up corner give way and develop cracks due to tension on the top. Now here you see because of movement of sand, number one, cause number two, because of curling up of corner due to differential shrinkages, because certain uh, components of or constituents of the building, certain materials of the building, they have different characteristics. Some are drying early, some are drying lately, and whenever such thing comes, like if glaze tiles are there, glaze tiles are non-porous and insulated with ceramic or vitreous coating, and they don't let the uh, what you call moisture evaporate, and that moisture, when it is collected within that loosens its corners, it tries to come out of the corners to escape into the atmosphere. Then little bit of corner upliftment is there, and whenever we walk on it, they develop cracks, and these cracks again are because of this phenomena of shrinkage, again a defect. Now, where here we come. This is what I had been telling you, that we do tiling over the RCC slab, and this let us suppose it is a mud, and thereafter this is tiling, and whenever there is percolation of water in it, and it when escapes, it become it evaporates and tries to escape, and it doesn't have any opening, and it just pressurize it upwardly. It lifts it upwardly, which means it curls up the upper layer. and thereafter it is escaped, and then it becomes hollow, and whenever any uh, uh, body is walking over it, or you will find that it will cave in. So that requires immediate attention of yours, because that accumulation of water may be corroding your RCC or steel in the RCC slab. So corner cracks in the panel of the concrete flooring occur because of the curling up of the corner due to differential shrinkage between the top and bottom of the slab. When load comes on the floor, curled up corner give way and develop crack due to tension on the top. So this is what I have tried to convey you in the very simple language. So this loss again is not payable. Now, cracking due to expansion of long brickwork wall, thermal expansion. This is because of thermal expansion. You would have seen that nowadays there are so many corners in the brick walls, especially on your terrace, used as a retention wall. So you will find that long wall is expanding towards x-axis, and a wall is again coming towards x-axis, and being x wall is the small in nature, and it could not withstand the pressure made up by both of the walls. So it will dislodge or may develop crack at its bottom, and definitely you have to redo it with some reinforcement, and maybe due to stitching method or whatever, but you have got to redo it. This is for your and your family's safety. This is a dangerous crack. You have to do it instantaneously, because you don't have to take chances for it to fall down. Then diagonal cracks in the brick masonry over lintel of the long span opening due to shrinkage of concrete. Now I want you to please express this.
This happens when RCC lintel
Um,
is placed and the brickwork is also done simultaneously up to the roof level.
Fine.
Now the RCC slab will shrink. Initial shrinkage will cause such cracks,
That's
and
correct.
these are more prevalent in new constructions.
Yes.
And how to repair them? We can say we don't have to use strong motor for it.
Okay.
We have to use less strength material, maybe ratio of 1:8 cement, or maybe it will be hide in while white washing. They will put some putty in it and close it. These
But
are not dangerous cracks.
verified. But these are not dangerous cracks. But these cracks could have been avoided only when proper time would have been given while constructing a
Yeah,
house.
slow construction, but
It,
modern days
they did.
require fast
Yes.
construction.
Yes. So this is, and again this loss is not payable. Fine. Now, vertical crack in brick panel wall of frame structure due to expansion of brickwork. So this is the crack in the brick panel wall of the frame structure, because the frame structure is first made and then it is filled in with the wall, which is called perfect party wall in our insurance parlance. And whenever such thing is, since RCC is more strong, it will try to push it outwardly, but it cannot, because of its own characteristics. Then it will bulge outwardly, and that bulging out outwardly is again because of expansion of brickwork, because of moisture contents, or maybe because of heat, or maybe because it has got pores to the extent to hold 3 times of its weight of water or maybe air. And whenever air is getting into it, it becomes compressed, and definitely that compression will expand its volume, and definitely it will bulge out. And that bulging out is again a gradual process, and is not payable. Am I right? Now here we come to vertical cracks at junction of two separate building blocks. Now these are the two buildings belonging to two different people, and definitely vertical crack at these two building blocks will always remain, because, as I have already said, no two cements can be matched, or they can be there will remain even if there is a gap of day one. So while we have to do we have to contain the seepage from the such sort of cracks because of rain which will come in between these two, you have got to fill the gaps from upward, or you have to plaster it so that that seepage is contained. And definitely this crack has nothing to do with any of the policy, because these are the demarcation. This crack is simply a demarcation of each other's plot length. So again, these sort of cases, losses, even if uh, it is within one person's property, say he has raised construction of one portion in 1 year, and after 2 years he is making or extending his construction, and this sort of thing will occur, and definitely uh, he cannot contain it, and after say 2 years 3 years, because of the expansion and contraction and other reasons which we have discussed, that crack will be evident. And definitely that is not the crack which has been caused by either of the named perils. It is only because two constructions have not been done in the same time. That is why this crack will occur. That is why I have informed you earlier that every dam, whenever it is made in uneven zigzag kind of block, so that seepage coming from one block is not passed on to other, because that other block is having its joint way upward or maybe downward. So this is how they built a big construction of cement, and they contain the cracks and seepage and other problems. Now, here we see this is the cracking and falling off of materials due to corrosion of reinforcement. This is what we have seen, discussed earlier. This is what we have seen. This is the picture you see. This is only because of this, and this is the cantilever. This is what I have been saying, that in side corner plots, they try to construct or they enhance their area by extending it to 2.5 feet. So this is what area we have been talking about. Now it is the initial cracking due to thermo movement and getting expanded due to vegetation. You see, again, uh, this crack, this is happening because of thermal movement and because of winds, or maybe uh, because of any reason vegetation has grown and its roots are going to make this loss more enormous. And you would have seen that most of the time this is people tree which is being spread by the bird uh, droppings, and most of the time it is not being touched. Being Hindus treat it as a very pious tree. They don't try to uproot it. So that's why these sort of cracks, they are means what you say, exorbitantly moving fastwardly because of the reason, number one, thermal moment, and secondly, it is accelerated by the roots of the tree. And here, this is when corrosion has taken place and the reinforcement has gave away because of the corrosion, because of oxidation, or maybe because of rust. Rust is also kind of oxidation. So that portion has fallen off because of its own weight, and it do happen after 20 to 25 years, maybe 30 years, looking to the conditions of or geographical conditions and weather conditions of a particular area. Now, cracking at the junction of two pillars due to differential loads in pillar, thereby differential strain. So here you see these two shops have been made at two different times, and they could not make it identical, and definitely, but their foundation was same. That is why this differential load is there. You can see a gap in these two pillars, these two beams here, and in these pillars too. They have tried to do it. So this differential strain, because this one is smaller pillar and this one is bigger one. You see, by putting in more and more of tar steel and cement, that doesn't mean that your structure is going to be very strong. It is not that. That is why you have to take help of a structural engineer to design whole of the structure of your building, because it is good for you and your loved one for safety purpose also, and it will save on your money also in shape of saving on your unnecessary putting in the reinforcement. Then vertical cracks in the boundary wall due to large tree near a wall and its roots causing the upliftment and cracking. So this photograph we have taken from Central School in Gandhinagar, and all the Jammuites who are seeing this, they can go and see the on the rear of the uh, uh, what you say, hospital. So this crack is very evident, and their parking of the car is there. And this crack is only because of the presence of this big tree, which you see here. This big tree, its root has somewhere come and it has uplifted it and it has damaged, and they have tried to repair it earlier also. And since it is a quite big, maybe 50 years old eucalyptus tree, and it is happening, and it will keep on happening even if they repair it times and again. So, and again, all these losses what we are discussing are not instantaneous. These are gradual in nature, and these are not payable. Now here we come. Here it is the explosion of a shop in Jammu area. You see how this has, sorry, you see how these cracks have happened and what is the condition of the rolling steel shutter. So you see in this photograph, this there was an explosion in this shop, and this wall was this perfect party wall between these two shops. It was blown outwardly inside this shop. So these are the cracks which are formed because of instantaneous loss, because of explosion. So these are payable. So this is how you have got to uh, make judgment of how which cracks are payable and which cracks are not payable. Now, these are cracks due to impact by railroad or animal. Most of the times our policies says. So this is how when a vehicle rams into any building and if any loss is there, you have got to pay. These are evident and these are impact loss and instantaneous loss, and it has to be paid, and it will be paid either by third party portion of the policy of the vehicle, or maybe by the building policy, maybe standard fire and special perils policy or householders policy or shopkeepers policy, whatever policy is. So this loss is payable because this is instantaneous and uncalled for and happened unexpectedly. Now, cracks and insurance policies. So operation of following perils can cause major or minor cracks in some cases. The cracks caused are previous to the extent being reason for the collapse of a structure. These perils are serviced in most of the policies, subject to certain exclusions. So cracks formation by fire or explosion, implosion, this is what we have discussed. Act of God perils. See, there are certain act of God perils, and everybody knows which loss causes which sort of losses. Now here I would say subsidence of land must is a uh, act of God peril, but it must not be confused with settlement of land. That is compaction of soil. So here your judgment will work more. Then aerial perils is there. Aerial perils is like day before yesterday, uh, loss has occurred to one aeroplane, or almost a month or 2 months back, one Pakistani airliner was fell on inhabitation and damaging so many houses, and loss of life was also reported. And it is because of terrorism like blast or uh, shooting or whatever. And other one is by the housebreaking. Housebreaking is whenever a thief or burglar is trying to make his forcible entry into or forcible exit from the insured property. So all these losses are payable subject to certain conditions. And since this is a very big topic, and now I would request that we will be picking up some of the questions, and rest of the questions, if they are much in number, we will be sending you all the answers by email. And I hope you all have enjoyed it. And thanks to all of you who have attended the webinar under the Gyan Ganga series. And I thank to Mr. Mulge and entire T3 team for their support. My sincere thanks to T. Ramesh Babu to provide the strategic technical support. My sincere thanks to Mr. Uh, Joshi for his support and acknowledgement and motivation all the times. And he is such a sweetheart of ours that without him we cannot think of doing any webinar. And my thanks to Mr. Mulge for making the institute regain its lost glory as an educational institution, though it wasn't a red carpet walk. And I request you all the attendees to drop your feedback at education@isla.net. And I once more thank to my co-host, Mr. Naresh Tagotra, who has been kind enough of giving his valuable
Yeah,
time to
Manchana.
be with me. Yes.
Thanks. Thanks,
Yes, sir.
Gyan Ganga series and Mr. Mugle and T3.
Thank you, Mr.
Uh,
Manchanda.
yeah, you're welcome, sir.
Yeah, the only thing is that the training at the rate isla.net, not
Yeah.
education. It's a training at the rate isla.net. So thank you, Mr. Manchanda ji and Mr. Tagotra ji for this wonderful session, a very knowledgeable
Yeah.
session. I hope all the members got now the clues how this cracks develops. It's a scientific with the scientific reason. It will help all the members. So thank you all the participants. Thank you, Mr. Manchanda, and thank you all the T3 team.
You're welcome, sir.
Thank you,
You're
Mr.
welcome.
Samir Joshi.
Yeah.
Right.
Thank you, sir.
Okay, sir. So there is any question,
Okay.
Samirji?
Sir, we have some question, but you see this already 1 hour and 48 minutes has been passed. So I don't think we have to take this question right now.
No issues, no issues. We can send them
Okay.
their
Yeah.
answers by email.
And most of the questions has been answered by in your slide. I can say because
Okay,
some
thank you.
questions are asked earlier, and in later slides the answers are there. So shall we conclude, Sachin sir?
Yes, yes. No problem. If is there one or two question we can take it? Quick question. So any questions? I think you have covered everything, so there was no question. The only
Thank you very much,
comment that
One
nice
question is from
session.
Mr.
It's a good thing.
Alok Mahajan.
Yeah.
How do we
There is
compare
one question that
structural
normally
cracks?
cracks are camouflaged.
Can you repeat it, sir? Hello? Hello?
Yeah, Sachin sir, internet is little bit disturbing
Okay,
because of the Bombay weather.
you read out the question.
How do we compare structural cracks with settlement cracks?
Yeah, in fact, I guess Alok.
Hello?
Hello. Yeah, sir. Yeah, my
Yes, sorry,
answer
I
to
was
his
lost
question.
my.
Yeah, I can understand, sir. Because of rains, you have got low connectivity over there. Mr. Alok, this is very good question you have put, and I guess you can enlighten us more because you are son of a very big contractor who is making big structures, and he can he can explain you much more. And I guess with his experience, you also tell us so that we may improve upon it. Anyhow, I tell you, as I have already said, uh, structural cracks and settlement cracks, they are different because structural cracks, they are the cracks in the pillars which are because of some of the reason, maybe load problems or design problems. Uh, those are very risky structures. But whenever there is settlement loss, the structure is tilting towards one end, and that way, or is developing a little bit of crack because of tilting or settling of the soil. So these are definitely very almost sometimes they are identical if it is only brickwork in the walls is there. But whenever it is a frame structure, settlement losses normally do not occur in it. But anyway, if they occur, so it is your experience being a civil engineer or being son of a contractor or as a old surveyor. So you have to apply your knowledge into it because every crack has its own story. On you can only comment on it until unless you see it. So anyway, I hope I try to. Otherwise, I have made everything very clear in the presentation that what are the cracks and how they are formed and what are the reasons behind it. And I hope I will be sharing with you all the presentation today evening, Alok, nothing to worry. But still, I would request you uh, to ask Uncle from my side so that I may make this presentation more lucrative and interesting. Yeah,
Okay, sir.
Smith. Yeah, yeah. Any other question, brother?
Sachin sir.
So there is a question from Mr. Usgaonkar, Vipin Usgaonkar, how to identify. Hello, am I audible?
Yeah.
Hello, am I audible?
Yeah, you are audible.
There is a question from Mr. Vipin Usgaonkar, how to identify whether loss is due to subsidence or a normal settlement.
Yeah, this is what I have. This is the same question, sir, what Mr. Alok has asked, and I have replied it. It depends upon your
Correct.
approach towards it. It is not overnight. You cannot learn it, sir. And every crack, as I say, it can be defined only when you go and you analyze all the things, including soil. Only then you can see ki it is settlement. Yes, settlement cracks do occur. There are cracks in the floor first. Thereafter, they go to upwardly. It is not instantaneous. The first crack will come in your garden, second will come in the pavement, then third will come in your floor, then fourth will come in your windows, then it will go upwardly. So this is a long process, and to know whether it is a fresh crack or old crack, you have got to see the cobwebs of spiders in it. You have to find out, and because they will define how much old it is, or maybe because of leftover of the paint or whitewash, you can identify whether a loss is new or old, that crack is old or new. So it is depending upon your own efficiency, how you are proving it is fresh or old one. Thank you. So any other questions, sir?
So there is one more question from Mr. Singh. How we can build a root barrier to avoid foundation cracks?
How can we build
A root barrier
root barrier?
to
Either
avoid
you have to,
foundation.
yeah, you then you have to go deep for that. Excavation must be deep for that. Otherwise, our compound wall of a normal house is not more than 1.5 feet down. So all those barriers, if you have to make, you cannot make. First of all, you have to see whenever you are constructing a house, don't try to reap any or sow any big tree near it to avoid such sort of problem. That is the only solution. Otherwise, no. And if any such tree is there, you have to cut it and you have to uproot it completely. You don't have to left the half stump in the ground itself, because it will revive someday and it will again try to damage your structure after 5 years, maybe 10 years. Yes, sir. Any other questions?
No, sir. Thank you very much. I think we have done with this today's session.
You are welcome.
Thank you all the members. Thank you all the panelists, Mr. Manchanda ji, Mr. Sargotra ji, and Mr. Samir Joshi. And thank you, team training and education. Without your continuous effort, we will not able to conduct this kind of webinar. Thank you, everybody.
Okay, Jay.
Thank you all.
Yeah. Thank you, boss. Thank you, everyone.